All right. Good afternoon, everyone. This session is about porting a Wayland Compositor to NetBSD and OpenBSD. My name is Jeff Frasca. I am a site reliability engineer and maybe a little bit of a strange person to be doing graphics work. I live almost entirely on the command line, particularly professionally, and generally don't care super much about what the GUI looks like. In fact, the compositor I've built is very keyboard forward and tries to avoid having much in the way of graphics at all. So, but it's one of those things that I got into it because I knew my X system was not going to be continuing to be supported going into the future, and then realized that I actually liked it quite a bit better. So, with that. Just want to get started with a little bit of an introduction to Wayland, because I know there's a lot of information out there and a lot of non-information, a lot of debates. It's a project that's got started kind of in the late aughts, so it's closing in on 15, 16 years old. It's part of the freedesktop.org group folks maintain the core of it, and basically when we had the Xorg server mature in 20 years ago as the modular system that we use today, a few people realized that you could take it apart and reuse a lot of the components and rethink the GUI protocol. Everything had been moving towards using higher performance for local applications, and people hadn't been using the remote applications on X Windows as much. And so everything's built around passing buffers of data. And then also, we don't have 2D acceleration in modern graphics hardware. It's emulated now. And so you can remove a lot of the legacy drawing features that X Windows has in its API because they're essentially effectively unused. So as I mentioned, it uses the modular Xorg ecosystem. So Mesa lib, DRM, kernel mode setting, all that stuff still applies. There's a library called XKB Common, which was them taking apart all of the keyboard handling stuff that's common across X Windows environments and building them into a library and then just reusing a lot of the keyboard map code. So there's a lot of things reused there. It's definitely something that is coming out of the Linux world and was born in the Linux world, so there are some Linuxisms. Libinput's a big one. But all in all, it's kind of a fun design. There's definitely a big rollicking community. There's definitely a lot of different camps even within it. So you get KDE folks and GNOME folks, and then a whole bunch of independent compositor developers like myself, and trying to figure out how to get things to work. But all in all, it's definitely not quite as mature as we'd like it for going into production, but it's getting there. And again, the modernness of it, there's a lot of fun stuff with how it can go faster and a few other things. It does have a few differences with security, and this is one that popped up from a couple. I added this slide at the last minute from a couple conversations over the last 2 days. So because there's no network aspect, it's done through Unix domain sockets for the protocol, and that ends up, you get a little bit more efficiency there, and you also get Unix file system permissions. But that does have a slight problem with it, and then the graphical data gets pushed around in DMA buffs, and the current form of that uses file handles to hand them off between processes. So you end up with a system where the Wayland Compositor assumes that everything's going to be run by one user, and so that tends to break accessibility tools. And so the accessibility story under Wayland is abjectly terrible. I make no excuses for that, and I'm hoping that we can figure out how to fix it in the coming years. But on the other hand, there's no network attack surface. You do get to leverage a lot more of the kernel security controls, and the protocol because you've got a combined window manager and display server, the input comes into the display server, and then it gets dispersed to the different programs. And so keyloggers can't go in at the high level that they can on X Windows, right? You can't sniff the input stream. You have to actually get down to the kernel level where the events are coming from. So there's a little bit of a better story there. Screensavers and screen locks are wildly non-uniform. I haven't looked into it for a couple years now because I haven't needed it. Mine doesn't support it yet. But that's kind of my next project. But like, that's definitely been a giant mess of how do we do screensavers. And JWZ has been like poking fun at various the maintainer of X screensaver has been poking fun at everyone because he's only been kind of one of the few people who's really been concentrated on having a screensaver system that actually locks the machine and doesn't let people like trivially bypass it with the right key press. So
successfully defends against the threat model of a cat on your keyboard.
Hey, no. I've had offices where like you had to have a secure screen lock, and if that wasn't locked down, the other guys would go hop on your computer and like send stupid emails or otherwise just prank you. There's certainly places where it matters. But it's, yeah. So, and like you'd like to expect that if you lock your screen, it's actually locked, right? So I will be digging more into that in the near future because that's kind of the next on my feature development list. But it's definitely not something that is, it's definitely one of those places where if you look into the history of it, you'll get a feel for like Wayland being a little bit of the Wild West. And then I've already said display server and compositor a little bit. Those are just kind of, they do the same job as the X server and your window manager combined into one process. And we'll get into more about why how that can be a big advantage. Surface and view, kind of the words I will toss around when I mean window. Surface refers a little bit more to, I'm talking about the drawable bit plane or drawable frame buffer in memory. And then view, I'm talking more about the data structure that the window manager thinks about when you're moving a window around on the screen. The seat it's an abstraction that's meant to represent a keyboard and mouse and monitor setup that, and this is one of the kind of the rough edges where you get the seat abstraction and it's set up so that there's a lot of like, where it clearly whoever sat down to do this meant it to be extensible so you could have a setup where you have a machine that has a bunch of terminals and different users and they're all working on the same composite at the same time. But then, as I mentioned, the compositors themselves tend to assume you're running as one user and only one user. And so there's a kind of a disconnect there. And I don't think anyone's really done anything complicated with that. I certainly haven't seen any compositor that works any differently than a typical X setup. And then the other, Wayland itself as a word is probably the most confusing word here because there's ways in which it is a wire protocol for a GUI application talking to a display server. There's ways where there's a library that FreeDesktop maintains that implements that protocol. And then there's the whole ecosystem of toolkits that support it and applications that support it and compositors and what have you. And I can hopefully it'll be clear from context which one I'm referring to. I'll try to be a little bit better about noting when I'm talking about the library or the ecosystem or just the protocol. Let's see. So, will you have to use it? No! X isn't going anywhere. This is BSD. We put it in our operating systems. You've got your X sets, and we have people that maintain it, particularly in OpenBSD and NetBSD. NIA had a post last year for the state of X Windows on NetBSD and went through like there is still active development on that X server implementation and even pushing back 2D accelerated drivers and hooking them up with more things so that like older machines will run faster and better. And And then Xenokera, clearly in OpenBSD, gets a lot of work and has had a lot of thought and engineering put into it. And I don't think that's going to be dropped, and there's definitely specialists there. Said if I was talking to a group of Linux enthusiasts, the answer on the Linux side of the world is only FreeDesktop does any work on Xorg amongst all the distros, and no one has any specialists there. Almost no developers in the distros have any specialty in keeping Xorg up to date. So, and the FreeDesktop folks don't want to work on Xorg anymore, so it's basically sitting. So like there's a little bit more of an impetus in the Linux world. And I kind of expect what's going to happen is that you're going to see more folks like me. Like FreeBSD already has pretty good support for it. OpenBSD has, in the last year, has gotten pretty good support for Wayland out of the ports tree. And it's just, so there's going to be a little bit more of it. It'll be an option, but no one has to really change what they're doing if you don't want to. Play with it if you do, or see something like. The other reason to welcome Wayland devs is that the display server, particularly like in the Wlroots section of the Wayland world, all the rendering is done through the fully accelerated driver pipeline. So you have to have the drivers working all the way and working well, which means that as we come in, we're going to come and fix bugs in the graphics drivers, and then that'll make the X Windows desktops faster and better accelerated and more stable. So like, it's not us trying to change things. It's just there will be ways in which we're trying to make things better. I've got, yes?
There is also a little Libdrm pipe that allows you to run like Wlroots compositors without accelerated graphics. Basically emulates it in software.
Oh, that's an interesting one. I'll come talk to me afterwards. I would love to find out about that project. But even still, like, it does me like I've got a couple like small changes into the NetBSD kernel that provided a couple of fixes along the way, and that's slowly been getting better. So we're here to help and have fun and be a part of the community. Like, and I don't want to move anyone's cheese. Okay. Moving on a little bit to how exactly does the protocol work. I'm not going to actually show any diagrams of the wire protocol because effectively that's so stable, I never work with it. The base protocol is very, very simple. There's a bit of object orientation to it where everything you try to ask the compositor about has an object ID, and so you provide an object ID and then an ID for the command you're trying to run or the request you're making and any arguments to it. And so it ends up being a very thin or very minimal standard for the wire protocol, and then there's a protocol development framework built on top of that, and anything you'd actually think of as a part of the protocol is built as an extension. And so the extensions are specified in XML, which I am not a fan of XML. I've never liked it. This was actually kind of like XML doing a thing that it's really good at and actually rather pleasant to work with. Like it's one of those, every technology it's written to do something, and there's actually even kind of the honor stuff has something it's good at. And this was a nice application of XML. So I've come around on that and don't hate it these days. So that has been fun. And as I was saying, like everything specifies extensions. So like the protocols around the talking to the compositor, the display, anything like even the core requests, they're just XML. They're defined as with XML protocol extensions within the Wayland library source code. And then what you end up doing is taking this XML file, running a program called Wayland Scanner on it, and then that generates little code shims, usually in C, to actually generate the wire protocol for you. And so you don't work with it. You just end up, the XML turns into a function API for the protocol, and you call those, and then it manages the wire for you underneath, and you basically never touch it. And I've never really needed to, like I had one problem that I was debugging where I tried to put a little bit of a sniffer application in between the application and the compositor, but I ended up not really needing that and not being super helpful. This is an example of what that XML looks like. It is taken from my compositor. I've got a custom extension for being able to interact with it with a command line tool. And so this is just a snippet, like how you might, the interface line defines the name of the protocol. There's some built-in like comments and things, and we're generally really good about trying to get the XML document to document itself or have its documentation contained within it to make it more readable. So you can learn a lot about how things work under the hood by just reading the XML files. This just sends an about, has a request block for sending an about request that just returns the version string of the compositor. And then it also has a request that calls the compositor to exit. And then, let's see, can we see that? We can see that, great. So if I do that, that just ran over, did the XK is it doesn't start up a window, but it does start up a talk to the compositor, and that's the version string for what I'm running right now. And then the rest of the demo is, this is running OpenBSD 7.7 on a framework laptop, and I'm using it to present the thing. So this is, yeah. What? Yes? Huh? Oh. I can also do, it's a little bit bigger. Yeah. So the demonstration is, hey, you can see slides. But and then this particular compositor, yeah, I don't have a logo. It's like, I'm not a graphics or designer, so like my favorite part of the graphics stuff is the really low level digging into Mesa and the kernel levels. So it's a stacking window manager, very keyboard and CLI forward. That right there, the drop-down terminal, that is the UI for dealing with it. The command line, in my opinion, is just better at anything you do with a mouse and pointer for most managing the computer operations. So just do that is the whole philosophy. It's also got that command line tool XK that has a lot of abilities to list the outputs, or get lists of the windows, and it uses an embedded Lua interpreter. I added it originally for configuration and then realized that because you have the window manager, has anyone here used Awesome WM or is familiar with it at all? A little bit, okay. It's an X Windows window manager that uses an embedded Lua interpreter as its configuration system, and it's really neat, well put together, but it doesn't do much besides once you've got it started up. The Lua runs at the beginning, and then you just kind of everything. There's no more interaction with it, so particularly. But because I'm the window manager and the X server all in one block, I can put callbacks throughout the compositor, and then have it be scriptable. So it's a stacking window manager, but you can have light tiling features where if you type in the impulse 2 command at the beginning triggers a Lua script, which started up my which started up the presentation. So you can do that. I've got the Impulse 1 is my like normal, starts up the browser and a couple terminals and then arranges them depending on how many monitors I've got plugged in. And then it uses kind of a tag system, not unlike Awesome Window Manager, so that you can have windows pop up on different desktops and basically using bitwise logic. So bad, it's perpetually alpha. I'm the only user. I haven't done the screensaver yet. If you were watching, I was shutting it down and starting it up when we were having the technical difficulties right before we got started because I don't have output hot plugging working. I don't like drag and drop, so I didn't actually add that at all. And I might at some point if like users ask for it. There's a lot I can do with Lua right now, but it's definitely like there's a whole bunch more that I would like to do. And then don't turn on the compiler warnings because it's the code base. I always feel like it's kind of a mess, but the reason for that is like I've been learning about all of this as I've been going along and have not had huge amounts of time to go back and clean up everything. So maybe in a couple years it'll be great. But at the same time, it's my daily driver desktop. I use it for work day in and day out. And then the other fun thing with the don't turn on all the compiler warnings though, porting it to OpenBSD was awesome. If you've never built and tested C code on OpenBSD, you really should try it, like particularly if you're maintaining a C project. It will beat you over the head with all of the memory management mistakes you've made because it does not put up with any garbage at all. It will just crash you.
It's like having Theo right there.
Yeah, Theo's right there going, which is awesome. You will get it. You will work out a ton of bugs, and like this is more stable and significantly better because I did this port over the last year. And so definitely going to keep OpenBSD in the regular like test bench and use, even once I get NetBSD up and running. I find NetBSD is a little bit better of a match for just how I like to use the computer, but OpenBSD is awesome and I love it. Okay. So now, to move on to my grittier favorite parts, when we start talking about how all of this is set up to work. Let's see, I'm trying to remember. Yeah. Okay, so this is kind of the basic diagram of how all of this is set up. You have an application, or rather, the compositor will start up. It'll open Mesa to deal with drawing and rendering and talking to the kernel from the DRM side to get the display set up. And then it'll do a little bit of mode setting. And then you'll have, and also it will talk to your input event source. And then an application, probably via a toolkit, will open up connections both to the Wayland Compositor and to Mesa so that it can set up a surface to draw to, and then ship that surface, details of that surface, over to the compositor. And then all of this is done with memory mapping. So you're not copying buffers. You're just passing around handles in a secure fashion and using the same blocks of memory. So when the compositor pulls the bits out and turns it into a frame, that's the only time you might possibly be doing a copy. And you're probably still not doing a copy. Instead, you're just sending it all down to the graphics driver as textures and saying, arrange them like this. And then it does the work of putting it together. And then, of course, everyone was at Margot's talk this morning, right? Y'all remember her diagrams about GPUs and how the hardware works? That's all sitting down here. And I don't have to talk about it terribly much. She did it for me, which is awesome. And then, so now next couple slides are going to be focusing kind of on the lower left-hand side of the diagram. I'm sorry, I'm bad at left and right. But first, pardon me, ioctl or IOCTL is like purely written vocabulary for me. If anyone has a preferred pronunciation, shout it at me. IOCTL, great. Tempting. Okay, but I see some grousing periodically online about IOCTLs are a mess, and actually, the harder I think about it, I don't think they are, because again, that first bullet point, file system is the UI abstraction of the Unix kernel. That's kind of what we really mean when we say everything is a file. Like you talk to the kernel through the file system for everything, and so when you're not dealing with like files on like a disk, you're talking about resource addresses like Unix domain sockets or device hardware or device files, and thus pieces of hardware. And so, of course, lots of hardware. You send data to it, you read data from it, and it can look like a file, and that works really well. And then some data, again, thinking back to Margot's talk this morning about how GPUs work, do not work at all well with that model, and they just need a dedicated API. But there's a good engineering trade-off with IOCTLs, and that is they keep the syscall interface in the kernel small and contained. And like everything I've seen is that the people complaining about it kind of want a higher level library with just a bunch of function calls, and then that turns into a mess that gets difficult to port, particularly when you have different architectures that have different amounts of room for a variety of system calls. So I kind of think if the people who are grousing about it are holding IOCTLs wrong. It's just the macro name is the function name. Just ignore the IOCTL there. It's syntactic sugar. The macro name is the function name. And then you have a nice function API. And the reason why I wanted to say this is because the DRM API is probably the biggest, most wide-ranging set of IOCTLs in the kernel for any of our kernels, no matter which BSD we're talking about or Linux, because you've got to deal with hardware configuration, video memory management, the drawing commands themselves, and any number of other like permission handling, passing around buffers, and none of it maps to a file operation. Well, you just need an API. It doesn't really make sense to like write to the device file for a DRM device. And then the API methods end up being very granular, and they end up being on a per card basis, and which is why we have Libdrm, and we'll get to that in a moment. But the other thing that's hiding in here is that you've got two device files typically. There's card0 and render D128. And OpenBSD used to have a different format, but most everyone uses this dev, DRI, card, and render these days. It's a privilege separation mechanism where anybody should be able to open the render node if they've got access to the graphics. And that's the one that just allows drawing commands and setting up buffers. And then the card0 device is for the DRM master, which is just one process on the machine. That's going to be the compositor in Wayland. It'll be the X server if you've got an accelerated X setup. And its job is to set up so that like the screen's got the right resolution and the actual real frame buffer that will actually go out to the screen and send the final drawing commands and what have you. And so that's there. This will come up again. But yeah. Okay. So to implement all of this with in our kernels, like fortunately AMD and now a little bit NVIDIA, they only care about Linux, but they did realize a couple decades ago that when they released the code and upstreamed it into Linux, It would be better if it was BSD licensed rather than GPL licensed, so it could be used across other operating systems. And so you'll find that I think OpenBSD 7.7 uses the code from Linux 6.12. NetBSD 9.10 and current, I think, are from a 5.6 kernel, and Dragonfly is a 4.4. And that all means like OpenBSD runs great on this laptop. It's relatively modern AMD hardware, and it should work on the AMD board that Framework just released, so I might actually be able to get the next upgrade and have things work. But it does mean that like NetBSD and Dragonfly work better with cards that are more around 10 years old. And then FreeBSD tends to be pretty up to date and tracks pretty well to as much as is available out there. But the other thing, though, is that one thing that there's a lot of things that Linux does where they've got procfs and sysfs, and we'll do things through that mechanism that we don't have and we don't need. So it ends up that we have a bunch of little modifications. There's a shim of code that wraps around the Linux portion of the drivers to adapt it between to like how does a device driver in a BSD kernel work, and then which means that you get this funny thing where if you're going through the code, there's a lot of traps in the DRM code where you'll have a structure that's the exact same as the one in Linux, but we don't use all of all the members of it. Like there are some things that are just not going to be set; they'll be null and can't be tracked through. And you just kind of got to be aware that that pitfall's there if you're looking at that code. And then, of course, we've all evolved a little bit differently over the years, and so every kernel does things a little differently. I'll have an example of that in just a moment. And then we often, again, to make up for the lack of sysfs and procfs, particularly OpenBSD, NetBSD, use extra ioctls. So we have even more added to the DRM API. And then Libdrm itself, again, that grousing that I see about ioctls, I think Libdrm is what they actually want, which is just a nice little library that sits on top of it. Part of the reason it's there is because, again, that the API at the kernel level is per card and granular, and the Libdrm API is a little bit more of like, hey, give me a file descriptor to the main graphics card, and then you don't care what the device file it is. It'll actually go through and Libdrm goes through and finds the one that's actually attached to the kernel, or all of them are attached to the kernel, and reports back. And then it'll also do all the things needed to open a file handle. And there's usually a little bit of extra setup work that goes into that. Which is why like a single Libdrm function will make a bunch of ioctl calls into the driver. And then on top of just having that Libdrm API, the AMDGPU has a whole bunch of extra ioctls. Novo has a different set. Intel i9-15 has a completely different set of its own. And so there is Libdrm Radeon, Libdrm, I think it's Novo, Libdrm Intel, and a few others to handle all of that complexity. And then so that largely hides the different drivers from Mesa. And so, or allows Mesa to have a lot of code that's more generic than it otherwise would be. But again, we all do it a little differently. So everything, like Libdrm itself, it's a small library, but it is kind of 4 or 5 libraries interleaved with ifdefs, one for each operating system, living in the same file. So again, because Linux heavily uses procfs and sysfs, and then we run different, and we do a lot of that through ioctls that are extra. So one example of that is DRM parse PCI bus info. So there is, you get every card, basically PCI is the bus that we use for GPUs in commodity hardware. And so you've got the PCI bus address, which is a domain number, a bus number, the device number, and then the function. And just a series of 4 addresses. If you've worked with PCI drivers, those will be familiar. If you haven't, just realize it's 4 small integers that tells you where the card got plugged into in the machine. But that information ends up in a couple places. But Mesa wants it when it's initializing a card. And so when you go, hey, open DRM file descriptor, this will get called somewhere in that process. Linux figures this out by tracking through and making a bunch of file system calls into like the sysfs file system. FreeBSD has a dedicated sysctl call that it makes, and then OpenBSD and Dragonfly added this DRM ioctl get PCI info to the DRM API, and that just literally you send it a struct that has domain, bus, device, function, and it spits that back out for the card. And then the NetBSD extends get unique, and the unique is a string that's set during the device initialization on the DRM master file descriptor, and it's built from PCI : and then the domain : bus : device : function, and so then you can parse that string out and get the numbers back. But there's a catch there. Remember get unique. That will come back and bite us a little bit. So should things be harmonized? I don't know. Works fine. All right. Just wanted to pop this up again since we're going to be, I think we're moving to the top section for a little bit more about application talking to both the compositor and Mesa. I do a lot of work with EGL, and so when the compositor starts up, it starts up EGL with platform DRM, which basically is kind of the same way that an accelerated X server will start up. It starts itself up, makes itself DRM master, and then sets up EGL to use with this platform DRM backend. And again, because it's taking on the role of the X server, so that is well supported across the vendor Mesas in all of the BSDs. Where the catch happens is when you get into applications. You can use Vulkan's kind of becoming more popular, and I think has less going on here. But I have yet to actually dig into Vulkan in any significant way, so don't trust what I say on Vulkan. But the Mesa will actually, in the EGL library, when you're using it to draw for a Wayland, it will do the buffer negotiation for you. So when you start up the application, it negotiates with the compositor to set up the screen, and then to set up the view and surface. But to set up the buffer, it actually dips through Mesa. So there's kind of really 2 lines there, where one of them is the compositor talking to Mesa to actually draw stuff to the screen, and the other one is the application talking to the compositor through Mesa to set up the buffers. And for what are probably obvious reasons, the vendor Mesa libs don't include the platform Wayland, because that then brings in a dependency on the Wayland libraries into Mesa, and then you'd have to build that. And it's a non-trivial addition to the build system. And if you've not dug into the code inside of Xenokera or the X11 sources in NetBSD, both operating systems go through. Mesa upstream uses a build system called Meson, and which is, if you haven't tried it, it's actually rather nice. I'm using it for my compositor, and I love it, but it's more stuff that you'd have to add into the base operating system to support it, and that kind of gets exponentially more difficult. So what OpenBSD and NetBSD do is they rewrite the Mesa build files as BSD make files, so that when they're running their builds to generate the sets for the installers, everything's done with plain old make, which is helpfully included in the base operating system and keeps things much simpler. So to support this, you'd have to add in Wayland code and figure out how to do a lot of extra work to get the Wayland scanner to run in a couple spots to generate all the files you need. So I kind of suspect the answer is to leave this as it is and find other solutions, because there's some degree that OpenBSD has done this, and we'll get to that in a bit. But on the other hand, NetBSD has like a really simple route to getting a Mesa with platform Wayland in it, which is don't install X11. And then get package source set up, and if you use the modular X server and just build everything out of package source that you need, you will wind up with a Wayland-capable Mesa. And I've been tested that a few times on both NetBSD 10 and NetBSD current, and it works great. There are a couple of caveats. Mesa lib and package source is on Amber, so if you're trying to play with newer hardware, it won't work, but also the kernel doesn't have a lot of support for newer hardware, so it won't work anyway. And then, remember I said that get unique would come back up again? Taylor fixed this in current a couple months ago, and but like it didn't make it into NetBSD 10. So right now, if you try to start up a Wayland application that uses EGL, it will fail because the get unique call will fail because it's not allowed on render nodes or denied on render nodes. And then if you just try to naively turn that on, you will crash the whole system because it only gets set up, the string only gets created for the DRM master. But Taylor did go and submit a patch or put a patch in to actually like extend that and make it report a reasonable string, whether you're a render node or or the DRM master. And it works in current, but then there's caveat 3, which I intentionally did not spell out because clearly all of this stuff is like very bleeding edge alpha. I'm one of the only people using it. It's going to crash on you. It's not going to work. Depending on which card you have, you will get better or worse results. I've definitely had a bunch of like inconsistent results, but I think that's because I overcomplicated one of my dev systems. So there's going to be lots of bugs. It's not stable yet. It's fun to play with it if you want to be on the bleeding edge and don't mind a little bit of instability. And hopefully, it'll make it into NetBSD 11, and then there will be better acceleration support across all desktops and better hardware support. And then I'll be able to play with this as a stable, reasonable desktop. With OpenBSD, when I first started playing with OpenBSD, I did this on 7.5, and I went through and I actually made a pass at hacking in Wayland support into the make files, and that ended up being like a bunch of like hand-hacked messes, which is kind of why I don't think we should go that way, or don't, not we, but like the OpenBSD team would be reasonable to say no, we're not going to do that. But with 7.7, there is now they've got a libinput port and a Wlroots port and a Xuake port, and that all works out of the box. And so when I reinstalled this spring and updated this machine, I was able to just like install everything that all of my dependencies from ports, and then my compositor compiled it on the first try, and then it ran on the first try, and then I was able to have apps pop up and display, and like once I got Qt all the way set up, like all of those apps worked great. I've been having a great time with Qt browser on this, and it's running really well. Firefox not running so great. There was some kind of regression. It doesn't like the mouse wheel events anymore, and that seems to be a Firefox thing or possibly a GTK thing. So the less straightforward thing is that my terminal emulator, the one that I popped up earlier, it's just an EGL application. Like, I have no toolkit on it. It's got no dependencies on anything other than like Mesa. And it did not start right up because, again, the only Mesa installed was the one from Xuake. But I was able, I've got a bit of a hacked install where I pulled down the upstream original Mesa tarball, diffed it against the Xuake source, made a few further modifications to that patched Mesa, and then built it using Meson, and then installed over the files in Xuake, and then a couple runs of patch elf later to clean up some stuff that gets dynamically loaded in that setup that's not there that gets statically linked in the BSD or in the Xuake make files, and it's working. I'm planning on writing that up and either adding it into my repository or actually finally putting up a web page somewhere. But I'll have those instructions sometime soon if you really want to play with that. But it might be better. The other route to go would be package source. I haven't tried it on OpenBSD yet, but the package source instructions that I have for NetBSD should work equally well on OpenBSD. And I think the other thing that I wasn't able to do because it involved a little bit too much RTFS is figure out exactly what trick they pulled and then rewrite my terminal emulator to just do that instead and then not have the EGL requirement. I suspect using Vulkan and then managing the buffer initialization myself will work, but that means learning Vulkan. And then let's see. And then the final bit here on this diagram is over on the input side is one of the other places where we've got some interesting stuff for BSD. So there's kind of two options. There's, again, libinput is the thing that Linux uses and was developed for Linux. And it is the default across the ecosystem. There are 2 compositors that don't strictly require libinput. Mine and SWC, which was, SWC was the ported to NetBSD by NIA. And because of that, we're the only ones that actually have an option for wscons. Libinput was, it's a re-engineering of the entire input system for Linux, meant to deal with like all of the modern layer of devices, like better handling for touchpads and touch screens and tablets and any number of wild and crazy things. It does hot plugging on everything, and it ends up being kind of, it feels over-engineered to me, and it's a little bit of a hassle to deal with because it's fairly complicated, and it really ramps up your memory management requirements. There was a whole lot of like, why did I have to chase down this crash? Oh, libinput like removed my keyboard. That like that was like fairly early on, a long time ago, but there was definitely like still kind of a little bit of a sore spot for me. But FreeBSD and OpenBSD definitely have very good support for libinput. Again, because they both have working ports of Sway. It looks like Dragonfly probably has it as well. I didn't super dig into that. NetBSD definitely does not have support for it, which was one of the challenges of getting my compositor working, because like my main goal is I want to use this on NetBSD and have that be my like workstation setup. So what does NetBSD have? NetBSD uses wscons, which is it was built for them to have for the base command line terminal video or terminal emulation system for when you're running a PC and you boot up to command line mode initially. And it's got some nice stuff to it. It really only handles displays, keyboard, and mice. The display is just a straight frame buffer, so not usable with the full graphics pipeline. But the input event multiplexers are usable. You get a WSKBD device and a WS mouse device, and any mouse and keyboard that the kernel know about will send events through those two devices. You never get hot plugging events. Your keyboard never disappears on you, and it works really well. It's delightfully simple. Again, possibly under-engineered in a couple ways because it was built for the needs of desktops in the 90s, and thus doesn't have particularly rich support for modern weird bits of hardware. But I typically use a keyboard and a normal mouse, so it's plenty for me. It does have some interesting quirks. It supports a lot of different keyboard encodings, but the two that I usually end up running are the PCAT and the USB keyboard map. And this laptop, the keyboard on the laptop detects under OpenBSD, and at least certainly the other laptop also has this problem. The keyboard detects as a PCAT keyboard. And so I'll get those events through the mux. But then if I plug a USB keyboard in, those events will also go through the mux, but they'll be in their respective map. And then when you ask the mux what the map is, you'll get one answer. And so one keyboard will spit garbage, and the other keyboard will not. Now, so I've been still kind of struggling with trying to how to work around this because I did want to check to see if there's a USB keyboard plugged in, but it turns out that the volume keys on this laptop go in through a separate keyboard device, and that ends up looking like a USB keyboard to OpenBSD. So it looks like I always have a USB keyboard plugged in on this laptop. But anyway, the other fun thing is that OpenBSD does something spooky that I haven't figured out yet, where it will have both keyboards will work fine in the console, and both keyboards will work fine in X Windows, but then I'll have the broken behavior in my compositor, and I haven't figured out what magic is going on under the hood there. The fun thing under NetBSD is that NetBSD does no translation whatsoever. So if you do this on a NetBSD machine, you will find out that your console will have one keyboard will work and one keyboard will print garbage. So it's at least consistently broken on NetBSD. There's some possible fixes to this. I'm probably going to bug people on both operating systems at some point in the next year. But again, and a lot of thanks to Nia for the SWC port, because that provided a nice example for how to work with wscons. Again, very simple, lovely thing to work with. So with my compositor, I have been tracking Wlroots I started this code base 6 or 7 years ago, and have seen every time Wlroots does a major rev, they have significant API breaking changes, and the last 2 rounds of that were things that I did not want to implement. And so I ended up vendoring the older versions and decided, because there's also a bunch of stuff that I just wanted to maintain personally and dig into and modify within Wlroots. Particularly, I've got some plans around how copy and paste is managed. So that ended up being the right decision for me, and it also meant that doing the NetBSD port meant I could just do it, and I'm not trying to convince a bunch of Linux guys to support this strange NetBSD backend. So the 2 big sticking points on Wlroots for me was the input backend. So it needs a wscons backend. There's and then the seat backend, the seat. They forked out the seat stuff into a separate library called libseat, and particularly on Linux and FreeBSD, that library does a bunch of work because it turns out it's fairly complicated to get from a virtual terminal up to an actual working GUI on those systems where you kind of just open the devices and start drawing on NetBSD, and it's fine. So I've got examples of those. The Wayland libraries in package source actually directly patch it to use KQ, and so it's more of a native native BSD style for even libwayland, and so that could be something that could be done if someone ever wanted to get Wlroots running on NetBSD. I would definitely happily advise. But I don't need to do it because I vendored that code and it works on my system. So I do have a lot of thank yous. I've mentioned Nia a couple times already, and Taylor at least once. Both of them have been extremely helpful. Taylor very directly. I don't know if he's in the room at all. There! You are wonderful to work with, and I have enjoyed every interaction I've had with you. You're super helpful. Thank you so much. And I would not have gotten anywhere near as far without Taylor's help. Nia has done a bunch of great blog posts on Wayland and NetBSD and X on NetBSD, and then did that SWC port, which I largely cribbed the wscons code from. Of course, OpenBSD dev team, and then OpenBSD ports maintainers. They've got, again, a working Wayland package tree. You can go run this right now on OpenBSD if you want to use Sway, which is a rather nice piece of code. I'm just not a big tiling window manager guy, and I had some other ideas that I wanted to implement. I've used Sway, and the Wlroots teams are also on my thank yous because I use them a lot as trying to figure out how does this thing work. I go read their code, and it ends up being a good way to look at it. Big thank you to the NetBSD dev team, the package source maintainers, freedesktop.org, and of course, all of the organizers and volunteers putting on BSDCan and letting me come up here and jabber at you for most of an hour. So there is a lot of future work that needs to be done. If you hadn't gotten the gist of it, there's a lot of this is just working in a few cases and kind of broken in a lot of other cases, and maybe it'll get there soon. The NetBSD AMDGPU drivers just need a lot more love. And then I need to figure, and that first bullet point's actually probably a bug on my plate for figuring out how to use the BSD Mesa without needing the Wayland support into EGL library. Still fighting with the mixed keyboard stuff. That's probably going to be I need to bring that up on the mailing list and discuss that. I would like to see package source split out Mesa. I've been using package source on Linux and have kind of most of a more advanced Mesa package. It would be nice to get that. I'm hoping to get time to set Mesa up so that it looks like Python, where you can pick which version you want and have the old Amber version be the default so that it doesn't mess with anyone's current setups. But if you want the newer, shinier thing, it's there and ready to go. Again, my compositor is great for my daily work, but there's a lot of stuff that I would love to see it be able to do. And then there's a couple of shutdown cleanup bugs. There's a good chance that when I turn this compositor off, I am not going to get keyboard input into the command line on OpenBSD. It just does that one time in 10. I have no idea why yet. And then the DRM shutdown code just is not there at all. You get to the DRM last close, and then the function that would normally go poke the WS console doesn't have any code in it. So if you start up the fully accelerated graphics queue and then shut it down, you wind up with a blank screen. But that's just a to-do that, again, it's a small team. We don't have a lot of people doing things. Not everything's getting done. It'll get there eventually. And then I should file bugs instead of surprising devs in a conference talk. So if you're hearing about this the first time, that's my fault, not yours. So there's a lot of stuff to be done. But it's all tractable and doable. And I'm super excited to be able to use this more. And it's very close. If I can just figure out how to be able to do the video calls for work, I'm going to switch over to OpenBSD for my work setup. But anyway, thank you all for coming to my talk. Do you have any questions?
How do you pronounce
I usually say Xuake. It is like, again, because of the drop-down terminal was definitely inspired by Quake 1. And like for a long time, I'd implemented a dirty hack which took Xterm and put it into a bigger window, and that the window hijacked the F1 key in my X setup and with a key grab. And that mostly worked and got me kind of this setup under X Windows. And then I realized with Wayland I could make it a better, well-engineered thing. And so the name was the name of my original dirty hack that I never published, and I decided to keep it out of like nostalgia.
Is it based on the Layer Shell protocol?
No, Layer Shell is about a thing I'm like planning to add in the next month or two, but this is literally, there is a special block in the frame drawing, or the output frame, that checks to see if it should draw this, and if so, it does it last. So it will be more on top than even the layer shells on top. Just because I want it, it is the UI element, it's always there.
Is this code in a public repository?
Yes, it is.
Worth trying to do anything with it if you're not you?
Maybe. Yeah, it's up on my source hut. If anyone's curious, I'm happy to. I should probably have put the link in here. I think it might be in the program. I don't remember if that got edited out or not. And I'm getting a time. So thank you all.